Hello folks, Tim Oscar here from Stonebait Games. I've been messing about with learning vertex shaders recently, and I thought I would show you a few fun things that I've been doing. Specifically a world bending shader which I've been having a lot of fun with recently. So just a quick demonstration. I've mocked up a very quick scene here, and I've attached my new shader to the material that is used in all of these objects. And I have a script here called the bend controller, and that controls the bending for the entire world. And I've got a few controls here, and I'll show you what happens if I vary some of them. So if I move the curvature up to positive curvature, you can see that the world bends down like that in a sort of convex fashion. And if I make it negative, the world becomes concave. I also then have additional controls such as the X scale and Y scale, X scale and Z scale, just to change the sort of relative curvature in the different axes. Reset that to 0. And a flat margin, which changes the amount of flat space at the center. So if I set it to 0, you can see that the curve starts immediately. But if I set it to, let's say, 500, there's a very wide sort of flat area in the middle before it then curves off towards the edge. 200 is about right for this particular scene, I think. In addition to that, I've got this thing which I've called horizon wave frequency, slider at the bottom there, and this controls how many waves you get around the horizon. So if I just drag that around, you can see it becomes a little bit crazy. I've no idea how this is going to be useful in any way, shape or form, but I thought it was pretty cool. And you can see basically it just adds extra sinusoidal waves along the horizon as you go. For example, if I wanted to do a sort of Pringle shaped landscape, then if I set it to 2, you can see that I've got positive curvature in one direction and negative curvature in the other direction. And that can be, I don't know, that might be fun for something interesting. You can make that double and have a sort of double wave going round. In addition to that, you can also change the origin of the where the curve starts. So here I've actually hooked it up to the main camera. So if I grab the camera and move the camera around, you can see that the curve follows where the camera is. The origin of the curve basically is matched to the camera itself. And also I've hooked up this reference direction, and that's actually the bend controller script itself. So if I rotate this, you can see that the curve or the wave rotates around with the direction that the bend controller object is pointing in. That might be useful for sort of fine-tuning the direction that you want your curve to go in. So let's reset all of that, set that back to 0. Okay, so there's a couple of interesting scripts to go through here. I've got the bend controller itself and also the shader. So I'll start with the shader and move on from there. Okay, so this is the shader code itself. I'm not going to go through everything about how to write shaders. There are some excellent tutorials out there. I've put a link to some excellent videos in the description below, but I'll just explain vaguely what I've done here so you get an idea of how it works. I've just taken an existing legacy normal diffuse shader, and I've grabbed that from the archive, and I've made some adjustments. I've renamed it to bendy diffuse hyphen radial. That's just in reference to the fact that everything works on sort of polar coordinates. And the shader that came in the legacy archive already had these properties. It already had all this stuff. The only thing I've added here is this addition which tells the shader that I need to make some adjustments for the vertices based on this vert function. The surface shader was there already, very simple. It's just a texture and a color. I've added this vert function, which all that does is take the position in world space and bends it into a new location before returning the adjusted vertex. And the bend function is where all the magic happens, and I'll go through that shortly. I've added a bunch of controls, so the stuff you saw in the scene where I was adjusting things like the curve origin and the reference direction, the curvature, and all those other things, those all hook up to here, and I'll show you how that works in the bend controller script shortly. But the main meat of this shader is this bend function. So all it does is it takes a vertex, so I've just used a half 4 here, so that's a 4 vector of half precision floating point. So that saves a bit of memory in the graphics card, and it just returns an adjusted version of that vertex. I won't go into why half is better than float and all that other stuff there. Those are covered in other videos. So the important points of this function is very simple. As you can see, there's not a lot to it really. What I do is I grab the vertex itself and I convert it to a world position. So this just makes sure that everything's working on world space, so that I can have a sort of global control over the curvature of everything in the world. I then calculate a vector, a 2 vector, which I've called xz dist. So this is basically just the distance from the curve origin. So the curve origin here. So the curve origin comes in as actually a 3 vector. I grab just the x and the z components of that. I ignore the y, so I can use just a 2 vector here. I take the world position of the vertex and I subtract the origin, and I then adjust by the scale. So the scale is the sort of relative x and z scale. Generally speaking, 1 is fine for the scale on both axes, but just in case you want to adjust that, that's fine. I then calculate the length of that vector. So this is a 2-dimensional vector, basically on the xz plane, and I calculate the length of it, and that's useful later for these next lines here. There's a couple of little tricks I do in these next 2 lines to make sure that I don't end up with some sort of dodgy floating point issues when the vertices are very close to the curve origin. So, for example, if I have a vertex slap bang in the center of the world space vertex, then effectively this vector is 0, has 0 length. So I need to make sure that the reference direction that I then use in this line here has a sensible non-zero length vector. So all I do is I lerp between the reference direction itself and the vector that I calculate based on the distance. So if the distance gets very small, i.e., well, let's say 0, then I just return the reference direction. If the distance is very large, say greater than 1, then it will return the vector itself. So this just gives me a guaranteed non-zero length vector for calculating the next step, which is the theta. This is the radial direction relative to my reference direction. So the reference direction comes in. Again, I convert that to a 2 vector using the xz thing there. I normalize the direction of the vertex, or the adjusted direction of the vertex itself, just to make sure that it's of a unit length. I then take the dot product between that vertex direction and the reference direction, and I have to do this clamp between -1 and 1. For some reason, the dot product can occasionally give you just slightly more than 1 or just slightly less than -1, a tiny fraction, and that really messes up this next section here, which is converting the dot product of those two vectors there. The dot product of that is actually the cosine of the theta. So to get the theta itself, I just take the arc cosine of that dot product. That gives me the theta in radians relative to the reference direction. So that's the angle between the vertex direction and the reference direction, and that's useful later. I then calculate, I then adjust the distance by the flat margin. So this is the area of flat space from between the origin and where the curvature starts. So if you want an area around your curve origin to be flat, you have this as a positive value, and that just makes sure that the curvature doesn't start until it's beyond this flat margin distance here. So I've got my adjusted distance there. I then take my world position Y coordinate for my vertex, and I subtract the what's the word I'm looking for? Parabola calculation of that distance, multiplied by the curvature, and multiplied by the cosine of the theta, multiplied by the horizontal wave, the horizon wave frequency. So if your horizon wave frequency is 0, then this will have no impact whatsoever. And if you didn't need to have any of that, you could just completely remove all of that, all of this stuff, because it's an unnecessary calculation. You wouldn't need to do any of this stuff either. You could ignore all that, and you wouldn't need the reference direction. But if you did want sort of extra waves around your horizon, then you can include that bit. So effectively, what this does is it bends the world in a parabolic function. So that may not necessarily be what you want. You might want a spherical version of this, in which case you'd need to adjust this, not only the y, but you'd also need to adjust the x and the z coordinates as well. But this is the simplest way of getting a world bending shader working, and it works pretty well for most situations, I think. And the majority of the time, you don't need the sort of spherical version. Finally, I convert the world position back to object space. So this takes the position in world space, and it converts it back into the object space. So it's effectively the exact opposite of this line here, and then I just return that object back to the vertex function here, and everything then carries on as before. So that's it. That's the clever bit. There's probably better ways of doing this. If you find a better way, please let me know. I'll be very interested to hear. But the rest of the code is in the actual bend controller script itself. So I will cover that next. So a quick reminder of what the bend controller looks like in the inspector. We have the curve origin, which is just a transform. Reference direction, which is another transform. I've used the main camera as the curve origin, and the reference direction is just the bend controller itself, but that could be any transform, doesn't really matter. A floating point curvature value, x and z scale, these vary between 0.5 and 2, just because that's a sensible sort of range. Flat margin, that can be any value, and the wave frequency. This I've got this actually as a floating point value, but really it doesn't. It should be an integer, because you don't really want it sort of halfway between. Integer values give you the best results. So I could change that. I just thought it was cool to show you how it wibbled like that. Okay, but let's take a look at the script itself. So this is the script. We've got all of our variables here that we can change. So we've got our curve origin, a reference direction, curvature, floating point value, and the x and the z scales between 0.5 and 2. And the flat margin, just a float, and the wave frequency is a float, but it should really be an int there. I've then made sure that all the properties that I want to set in my shader, I've converted the strings into IDs here. So for every property in the shader that I need to change, I just convert in the start function into these integer IDs. That's a little bit more efficient, because since I'll be updating the shader values every frame, just in case you need to adjust things on the fly for some cool gameplay effects. The other thing I've done is I've added this execute in edit mode, so that you can see that any changes you make to these parameters get reflected immediately in the editor. That's quite a handy little tip if you've not seen that before. So the other thing I do is I just check to see if the curve origin is null. If it's null, then I do some other stuff down here, which is related to a game. If you want to actually change the way the curve origin is adjusted in the game. So let's say you switch to between characters or something, you want the curve to adjust depending on that, and so that can happen there. The details of that aren't that important. What is important is what happens in the update function. It's all pretty straightforward. All I do is I have a scale function here, and this basically is just a vector, and it allows me to convert the two floating point scale values here into a vector, which is more efficient for the shader itself. That particular one is set to the well, where is it now? Yes, there you go. The scale property in the shader. Everything else is set as you'd expect. The only other thing I do is I make an adjustment to the curvature. What's that? That's about a 10,000th. No, sorry, 100,000th. And that's just because the curvature value itself that I set would be a little fiddly to be messing about down at tiny values, because the world that I'm bending is quite large. So I just adjust that here, and so that means that happens once a frame rather than once every vertex per frame, which is what would happen in the shader if I did that adjustment within the shader itself. And that's it really. There's not a lot to it. This just means that I can move the curve origin in real time. So let's say I've got my character walking around and I want the world to bend around him, then the curve origin can be adjusted to, or the curve origin itself could be the character, and as you walk around, it makes sure that the shader responds to that. This is very neat actually. I discovered this recently. This shader set global vector, or set global float, or whatever it happens to be. These are really useful for controlling multiple shaders that all have the same properties that you want to change. So let's say I've got different materials with different shaders in my game, and they all use the bending adjustment. What you don't want to do is to have to change the values for every single instance of that shader that's on every object. So what you do is so this is back in the shader code, rather than putting all your properties up here in the properties section, you hide them away. So down here in the sub shader, you'd normally have these and the equivalent up here in the properties, but that means that you can't adjust these globally. You have to adjust them on a per shader basis. But if you leave them out of the properties, that means that you can use this set global functions here that can change multiple different shaders all at once, and that's really helpful. So that's it. There's really not much to that, and I'll show you how it looks in the game. Okay, so this is what it looks like in game. I've just knocked up a quick test scene here using some assets I bought from the asset store, the cartoon low poly pack, and it comes with various trees and houses and mountains and such like. All the trees I placed using a prefab brush tool by the guys at Hollow World Studios. Very handy if you need to place a lot of objects in a sort of semi-random manner. That's really useful. I just thought it'd be nice to have a sort of small scene, little village with a few houses and some mountains in the background. If I freeze the camera there and adjust the curvature, you can see if I increase the curvature, the mountains sort of disappear over the horizon, and if I unpause the camera and then sort of fly along the landscape, you can see that the mountains sort of rise up over the horizon like that. And if I look back towards the village, you can see that's now disappeared below the horizon, and I can sort of fly back in that direction, and it should. I think I've lost it somewhere. Don't know where it's gone. There it is. And you can see that the mountains all now disappear back down below the horizon. Conversely, if I vary this so that it's negative, you can see that the mountains sort of rise up into the sky, and I can look around and see everything off into the distance. Now, of course, you've got to be careful with exactly how you do negative curvature, because you can have situations where you can see the edges of the world like that. And there are a couple of other caveats you should be aware of when using these sorts of bending shaders. If I make this curvature really extreme, so right up there like that, sort of crazy inception type effect. If I then sort of look up towards the sky, you'll see that the ground disappears and then all of the mountains pop out as well. Now this is because in actual fact I'm not moving the objects at all. They're exactly where they used to be, down here along the horizon. So the natural frustum culling that Unity does for you to improve performance means that when I get up to about there, the horizon, the actual ground mesh disappears off below the frustum of the camera, so it gets culled, and then as I go further up you see the individual mountains get culled as well. That's something to be aware of if you're going to do world bending in that particular direction. If you want a sort of negative curvature, there are ways around it. You can set the meshes to not cull, or you can increase the extents of the mesh in code so that they're much taller than they should be, so that the camera doesn't cull them quite so much. But if you use positive curvature, then it's not such a big deal, and you can probably get away with it. The other thing you can mess around with here is, for example, the margin. If you set it to 0, you can see the curve starts to bend immediately, but then you can get some interesting artifacts where the shadows don't appear in the same place as the objects themselves. So I wonder if it can be shown by moving up a little. Yeah, there you go. So you can see sort of just here the shadow of that tree is actually sort of hovering in the sky, which is a bit weird. So what's actually happening is, I think it's the lighting model that's used in the surface shader itself is rendering the shadow where the object actually is, whereas the bending shader has moved the object below where the shadow should be. So that might not necessarily be a problem if you've got a decent margin like that. So if you have a flat margin which goes beyond the distance of your shadows, where your shadows are rendering, then actually it's fine. But if you want your curve to start immediately, then you might have problems with that. So I suspect there's a way of dealing with that by writing a proper fragment shader that deals with all the shadows in the right way. But I haven't figured out how to do that yet. But that's something to be aware of for bending shaders like this. So there you go. That's my world bending shader. I hope you found that useful. And if you have any other tips or tricks that you think might be handy, let me know. I'll be very interested to hear about other ways of other techniques for doing world bending shaders. In particular, spherical shaders. I haven't worked out how to do that yet, so I think that's just a case of working out the maths for the geometry. But it's kind of fun. Not sure if it's hugely useful for what I'm working on right now, but maybe in the future that'll be useful to implement something like this. Thanks for watching.